Welcome to aminacademy.com. In organic chemistry, let us discuss about properties of alkanes. Alkanes are sometimes referred to as paraffins, a word derived from the Latin parum affins, meaning little affinity. An alkane is also called a paraffin. It consists of a carbon and hydrogen atoms bonded by a single covalent bond in a tree-like structure. The general formula for alkanes is, we know that CnH2n plus 2. We will see about the properties of alkanes and their variations. The structure of methane, we know that CH4 is given below, is one of the most common alkanes. Look at here. Here CH4 plus chlorine, Cl2. That is, it's react with chlorine, gives, that means with light or heat energy given, is changed as methyl chloride, that is CH3Cl plus HCl. Continuously CH3Cl, that is methyl chloride, is again react with chlorine, gives CH3Cl2, that is methylene chloride and HCl. And further this CH2Cl2, that is methylene chloride with further chlorine, gives CHCl3, that is chloroform, plus HCl. Further CHCl3 plus Cl2 gives CCl4, that is carbon tetrachloride plus HCl. This is a continuous process. Now we'll discuss about properties of alkanes. Physical properties of alkanes. Alkanes are colorless and odorless. They possess weak van der Waals forces of attraction. Alkanes have for 1 to 4 carbon atoms or gases, that is methane, ethane, propane, butane, or gases. Then 5 to 17 carbon atoms, they are liquid. And alkanes have 18 or more carbon atoms or solid in 298 Kelvin. Structure of alkane. In alkanes, all the carbon atoms are sp3 hybridized, which means that they form 4 sigma bonds. It have 4 sigma bonds with either carbon or hydrogen atoms. Their general formula, we know that CnH2n plus 2. The bond angle between them is 109.5 degree. And they exhibit tetrahedral geometry. Look at this melting point and boiling point. Now here number of atoms, carbon atoms in x-axis, it increase like here the room temperature is in y-axis. That here this is the graph source. That boiling point of the alkanes increases when increase of the number of carbon atoms. Shorter chain alkanes have low melting and boiling point, but as the number of carbon atoms in the chain increases, the melting point rises. Boiling point, it increases with the increase of molecular weight as the van der Waals forces increases with the increasing molecular weight. Straight chain alkanes have a higher boiling point than their structural isomers. Melting point, it is also increases with increasing molecular weight because it is difficult to break the intermolecular forces of attraction between higher alkanes as they are generally solids. Even numbered alkanes have better packing in the solid phase than the odd ones. Suppose in alkanes number of carbons is even number, then it is having better packing in the solid phase than the odd ones. They form a well-organized structure which is difficult to break. Hence, even numbered alkanes have higher melting point than odd number ones. Solubility. Alkanes are generally non-polar molecules because alkanes have non-polar molecules because of the covalent bond between Cc and Ch, and also because of the very small difference between electronegativity of carbon and hydrogen. We know that the polar molecules are soluble in polar solvent and non-polar molecules are soluble in non-polar solvent in generally. So this implies alkanes are insoluble in water or hydrophobic nature. Alkanes are insoluble in water or hydrophobic in nature. When a non-polar alkane is added to a polar solvent, the water molecules are attracted to each other and alkane molecules are attracted to each other, but water and alkane molecules do not attract each other. And in organic solvent, they are soluble because the energy required to overcome existing van der Waals forces and to generate a new van der Waals forces is quite comparable. Alkanes have lower density than water. They float on water. Density increases with an increase in molecular masses. Apart from weak van der Waals forces, London forces, dispersion forces, weak intermolecular forces act between the molecules of alkanes. Chemical properties of alkanes. Combustion of alkanes. Here, CH4, for example, look at here, methane plus oxygen gives CO2 plus 2H, H2O. Now we're balancing this CH4 plus 2O2 gives CO2 to H2O. The excess of oxygen O2 alkanes readily undergo combustion producing carbon dioxide, gas, water and energy in the form of heat and light. Here with energy of 890 kilojoule per mole. That is in word form, alkane plus oxygen gives carbon dioxide plus water plus energy. This is a basic formula for combustion of alkanes. The above reaction in the combustion reaction of butane. Here butane is CH4H10 plus 6.5 O2 gives 4CO2 plus 5H2O, that much energy, that is 2874 kilojoule per mole. The above reaction is the combustion reaction of butane with the increasing molar mass of straight chain alkane and energy released increases. Also with the increasing carbon chain length, the combustion energy increases. That means more carbons contained, that alkanes have more combustion energy. In the absence of sufficient oxygen, alkanes try to undergo incomplete combustion. Incomplete combustion produces water and carbon monoxide or carbon. So better having complete combustion of alkanes because this monoxide is toxic. Halogenation. Alkanes are less reactive. Without ultraviolet light, they do not react with halogens. With UV light, that is ultraviolet light, halogenated alkanes is produced. It is a substitution reaction in which one or more hydrogen atoms are substituted by halogen atoms. For example, CH3, CH2, CH3, that is methane ethyl propane plus Br3 bromine gives CH3, CH2, CHBr plus HBr. Here, propane is reacting with bromine. The general substitution reaction equation can be as given as RH, that is alkane, plus X2 halogen gives RH, 1X halogen goes with connect with alkane and halogen with X, HX. So this is a basic reaction where R is a carbon chain and X is a halogen. So substitution reaction. Uses of alkanes. Because of the properties of alkanes, they are quite useful. Some of the uses are propanes and butanes are used in propane gas burners as a propellers or aerosol spray when liquefied at low temperatures. Pentane to octane fuels are good for an internal combustion engines. Nonane to hexadecane have high viscosity and find use in diesel and aviation fuel. Up to C35 alkanes are used as paraffin wax candles, as anti-corrosive agents, and in lubricating oil. Higher alkanes are cracked to smaller alkanes and then brought into use. Alkanes are the basic hydrocarbons that are bonded through a single bond. They are saturated hydrocarbons. These are, we discussed is some physical and chemical properties of alkanes. We have done. Please subscribe our YouTube channel.